Hello guys, I'm here to explain LeetCode question number 2920, maximum points after collecting coins from all the nodes. So in this question we have to collect coins from every node and we have been given a tree and the corresponding edges for that tree. Okay, as you can see this is a tree and this is a tree. So what do we have to do? We have to collect coins, but there are certain conditions if we are collecting the coins. Okay, so first is that we have to there are two ways that we can collect coin from any node. Okay, the first way is that we can just simply collect the coins, all the coins, but we will only get coins num total coins minus k. We are given k. Okay, so the coins that we will be getting will be coins minus k. Okay, and this number can be negative also. Okay, the second way is that we can collect all the coins, but we will get only half amount of that. In fact, we will only get the floor value of that number upon 2, and also subsequently all the nodes in the subtree of that node will also get reduced to upon 2. Okay, by the floor function of that number of coins upon 2. Okay, so there are two ways that we can pick the coin. So by choosing the ways optimally, we have to find the maximum points that we can fetch from the tree. Okay, so we are given this problem. Now how can we approach this problem? Okay, what we can do is we can simply perform DFS over each and every node and just iterate through every node in different ways of fetching the coins, and just using the value that we get from the nodes we can compute the answer. Okay, that can be done. For example, from 0, if we are choosing way number 1, we will get 0 has 10 value. Okay, 1 has 10, 2 has 3 value, and 3 has 3 value. Okay, so if we are choosing way number 1 to fetch from 0, we will get 10 minus k equal to 5. So 10 minus 5, that is 10. Okay, cool. Now we have moved to 1. Okay, if we choose, okay, if we just choose by choice that we want to go with this operation, right? So what will be done is this, we will get 5, right? 10 by 2 equals to 5. We will get 5 coins, and also this will become 3 by 2, floor function of 3 by 2, which is 1. This also become floor function of 3 by 2, which is 1, right? So these nodes will now have these new values of 1, right? So in this way we can perform our approach, right? So how to get the optimal answer? Okay, what can we do is we can just do like both the approaches for each and every node, right? Like for 0 we have done 10, we have done first method and then second method, and for the each of the nodes we also do first method and the second method, and so on for every node, and just compute the maximum out of all the nodes. Okay, so let's try to do that. Okay, also one more thing to consider here, like if we think of going with only and only a second way, right? We have to keep having the values of the upcoming nodes also, right? For example, here we had the value 10, 10, 3, 3, right? If we choose to make this as 10 by 2, okay, this will become 5, this will become 1, this will become 1. Okay, now we come to this node, right? If we choose to halve this node, okay, this will become 2, and these will become 0, and these will become 0. Okay, so what are we doing? We are passing on number of times we have to halve this node. Okay, so here we have 0. Now here we got 1, we got 2, we got 3. Okay, in this way. So So we have to manage all these things. That can be done using DFS, okay, but that will be pretty slow, so we will try to optimize it using memoization. We will see how I'm doing it, okay. So let's begin with the approach. First we have to make an adjacency list graph for these edges. First the size will be hs dot size, because we are given here edges dot length is n minus 1, so we have to increase 1, okay. Now let's make the graph. This is an undirected graph, so I am connecting both nodes to each other, right? So that's how it goes. Okay, we have made this. Now we have to make the function also, right? We have created the graph. Now let's try to make the function that will return return the maximum value for that node, okay, if we choose any of the ways, okay. You will get to know what I'm doing, okay. It's not very complicated. This is a lambda function declaration that I have done here, okay. We are accessing the external values by reference in this, okay. Oh, also we have to pass one more argument, that will be number of times we have to halve that node if you are going by the second method, or that's a consequence of the ways that we used in the previous recursions, okay. So I will just explain how, okay. Okay. I am declaring these two variables, okay, that can be used, because what if we go with the first way and what if we go with the second way, okay, we have to consider both of them. So answer one will be if we choose to do this operation number 1 on the current node, and answer 2 will be to fetch that value which will be used when we are using this second operation. So I've done this, okay. Now we will iterate through all the neighboring elements of that node. Also we don't want to again go back to the parent node, okay, because this is a tree. We don't want to go back to the parent, so I will just declare, okay, int parent, okay, cool, we are done. And we don't want the child to be parent, okay. Oh, this is answer 2, okay. Now I will show you what I'm doing, okay. So answer 1 is DFS, and the parent will now become the current node, okay. Cool. Now for answer 2 is count plus 1. We have to do count plus 1 here. Why? Because if we are choosing this way, we have to reduce the next element by 2, so we have to increase number of times we are dividing that number by 2, right? So we have to increase by +1. So I have done that. Now this will be the current value, right? Coins of node. And we have to decrease the value by 2, power of 2 comma count. Okay, so we have decreased that. Now we will simply return this value, maximum of current value minus k plus ans. Okay, and I will explain in a while why I have decreased k. Okay, comma current value by 2 plus answer 2. Okay, now let's discuss this line. Why I am returning this, why I am decreasing k here, because for answer 1 we are what we are doing, we are decreasing k from the current node. Okay, so that's why I decreased k. But in the second operation we are dividing that number of coins by 2, so I just did that. And what I'm doing here, I am doing all the reductions and all the divisions that we would have done in the previous iterations, in the previous recursions. So I just performed that here, and in the end I just return the maximum value. So our recursion function is, I think, done, but we will also dry run that in a while. Okay, and I can just simply return that and count 0. Okay, let's see, is there any error? Okay, no, I don't think there is any error as of such. We have decreased an error and just we go with this. I think this is done. Let's try to run this code and check for any silly errors or anything that I missed. I hope there are none. Apparently there are none mistakes, but as I click on submit, there will be a TLE error, and we will discuss why. Okay, let's submit this code. There should come a time limit error, time limit exceeded. Yep, as you can see, it got exceeded it because for some nodes, for some pair of node and count, this can be a repetition, right? We might be calculating this pair again and again. Okay, so we have to fix that. So what we can do is we can just keep this into the memo and move ahead. Okay, so we can just create a memo here. Okay, okay. Now this memo will have all the values of count for each and every node, right? For example, for node 2, for node 2, there will be values for like count 3. Okay, so on so on, and count for that we can access. Oops. We can first check if there are such values. Okay, if memo dot count, we will just simply return okay, cool. Okay, and Indian we have to save also. Now this should fix the problem. Let's see. Oh, it will test all these cases, but we have to also use this as our test case. So let's just use this as our test case and run. This should run. This should work apparently, or should not. Let's see. Yep, it got accepted within 106 milliseconds. Now let's submit this code. Again, it might throw time limit error because we will just see why. Okay, 537 test cases passed. Let's see how many get passed now. 540 test cases got passed. Now only 2 remains. Okay, so so let's discuss some math here. Okay, as you can see, this integer count represents number of times we are gonna divide any number. Okay, the maximum limit for this coins of I is 10 to the power 4, which is 10,000. Okay, if we have this count, if we are going to divide this number by 2 more than 13 or 15 times, it will always give us value 0. Okay, so for example, if I divide this number by 2 to the power 13, it might give 0. So let me check what is the value of 2 to the power 13. That's 8192. Okay, so if I divide this by 2 to the power 14, it will give 0. Okay, so what we will do, we will just perform this second DFS only when the value of count is less than or equal to 13. Okay, so that we don't keep iterating for count values more than 13 and just get simply 0 and just do work unnecessarily. Okay, this got us error, right? So let's just add this in our test case and run our code again. Yep, it got accepted within 1607 milliseconds. Let's just submit this code and hope for the best. It should work now. Yep, it got accepted, right? So this was my approach, right? This was my approach for this question number 2920, maximum points after collecting coins from all the nodes. And I hope you like this approach, and thank you. See you with the next one. Please drop down the comments you might have that I can solve. Okay, thank you. Bye.